today's concept is crystal defect. What is defect? Before going to the defects chapter, where we have to know about what is defect. Defect is a Latin word which comes from the defectus, which has meaning of that failure or these are crystal. Before going to defect of we know what is defect, that's after we have to go the crystal. Crystal is the continuous structure of the atom, where atom are arranged in a continuous structure, that's called crystal. And another one is amorphous, where amorphous is this is the discontinuous structure of the atoms. This is called amorphous and this is crystal. When the continuous structure is break or in somewhere or anywhere, that is called crystal defect. Sometimes defect is good or sometimes defect is bad. That does not mean कि defect means failure. That means कि defect is a bad thing. That sometimes it gives us strength and ductility and hardness. That such of things comes from the defects. And these are crystal defects. Crystal is a defect, and we have to go. These are four types of defects are there. First is point defect, that's after the line defect, and volume surface defect and volume defect. Line defect, point defect is a zero dimensional defect. That means when we are giving a point, or point means this is a point. This is a point. When point comes, it is a zero dimensional. That means there are no dimension is there in point defect. So this is sometimes it comes dimension, but we are considering this as zero dimensional defect. Where is line? Line is a that can be x axis or y axis or z axis, that can be line. So it is a one directional defect in line. When this comes to surface defect, is a two dimensional defect, or it is a plane. We are also called it is a plane defect. When we have to go for a plane, these are things when two axis we are considering two axis, then it goes to plane. That's so it is considered as surface defect as a two dimensional defect. When volume defect is a three dimensional defect or 3D defect. We are going to learn today as point defect. Point defect, there are five type of point defects are there. In first one is vacancy, that's after interstitial, that's substitutional, and Schottky and Franklin. When we come to vacancies, that in vacancy defect, these are crystal. When crystal comes, there is continuous arrangement of the atom are there. This is called crystal. When one atom is missing in the crystal structure, that is called vacancy defect. In vacancy defect, one atom is missing. That's reason the defect arises, volume defect, vacancy defect arises. In vacancy defect, the crystal structure have less strength or less volume occurs. So in volume defect, we have to go, we can call it is a point defect, or it has less ductility or brittleness as arises. When we go to the in vacancy, there are temperature, high temperature, due to high temperature, and there are frequency irregularity. So the vacancy defect are causes. In order to 1 EP is the vacancy defects thermal energy. When vacancy defects arises, it is the thermal energy in the crystal structure arises, and it is shown in the that's previous figure. As we see in this figure, it is the vacancy defect in the crystal structure as arises in vacancy defects. That after we have to go interstitial. So in interstitial defect, when interstitial defect, one atom, there are in crystal structure there are anion and cation. As we know, in NaCl, Na is plus charge and Cl is negative charge. The size of Na is less and size of Cl is higher due to its periodic structure. And Na is the 11th number atom and Cl is the 17th number atom. So the radius size of Cl is greater than to Na. So in the interstitial defect these are the continuous structures. When one atom comes to the interstitial position of the total structure, this is called interstitial defect. Mainly the cations are comes to the interstitial position due to its less size and low high charge defects. In NaCl this is called the interstitial defect. These are the definition of interstitial defect. And impurity, we can also interstitial impurity are same type of defect. Bulk matrix, atoms and bulk matrix means bulk means in the large numbers, then and cation and anion there, then the interstitial defect arises. Also in steel or carbon, these are the interstitial defect arises. We are 0. In radius of 0.7. As I say, the cation are less in size and anion here. The cation are less in size and anion are higher in size. Due to this, NaCl, Na goes to the Cl interstitial position of the Cl in interstitial defect. Next, Schottky and Frankel defect. In Schottky defect, as I see as I considering the NaCl's crystal, NaCl is a crystal, as it shows the continuous structure, it is a NaCl crystal. As considered, it is Na and these are Cl. These are positive ions, these are negative. As is continuous, it is also Na and it is Cl. Na plus Cl minus. When one anion and one cation is missing from the lattice, it is called Frankel defect. Due to this defect, total stability of the crystal structure don't be less or high, because due to one cation and one anion is missing from the after the crystal Schottky defect, the structure will be that like this. One cation and one anion is missing from the lattice Na and it is Cl. As all are it is Na, Cl and Na and Cl, as one Na and one Cl is missing from the lattice. But the electron from due to this is considered in NaCl and CaCl, these are the 17th number table and Na is the 11th number table. These are the lower atoms and the lower radius of the atoms, and in Cl these are the small greater in radius size. So it come to the interstitial positions. But in Frankel defect, it is in Frankel defect, let's consider it is a lattice. A CaCl lattice, let's consider a CaCl lattice. It is Cs, it is Cl2. or let AgBr we can consider also LgBr, AgBr. These are the continuous structures of Ag and Br. In Frankel defect, what occurs? One into, as we know, the cation are in less in size and anion are greater in size. That's why one anion is goes to the one cation is go to the interstitial position of the another cation due to let's see, these are the anion are there. These are voids. Void means the vacancies. Void means vacancies. Due to large in size of anion, there are large vacancies are the voids are creates. That's why cation goes to the this interstitial positions of the cation. When the one anion is missing from the lattice, the electronic stability decreases of the in Frankel defect. These are the positive ion, these are the negative ion. Likewise, negative ions are greater in size and positive ion are less in size. In let's see, in Schottky defect, both the anion and cation are missing from the lattice. Wherein Frankel defect, one anion is goes to the one cation is goes to the interstitial position of the anions. Understand? Substitutional. When it is a defect, when the foreign atoms comes to the foreign atom means as you consider CaCl2. In a substitutional defect, one foreign atom comes to the lattice and it is considered comes to the anion or cation position of the lattice. This is called substitutional defect. As I see the crystal structure of the CaCl2, it is Ca, it is greater in size, positive Ca plus and Cl minus. When the foreign atom comes, let's consider we are adding some Br. Okay, then it is Ca comes to Ca goes to the interstitial replace the Cl and it goes to let it's Ag. We can also consider Ag as we know in the previous example. AgBr, Ag and it is Br. And it goes to Cl and we consider foreign atom as Cl. Cl comes and Cl replaces Br and it comes to forms AgCl. It is substitutional defect. Zinc atom, when it is the figure are there, when the foreign atom comes and replaces the lattice atom, that is cation or anion atom. The brass, in brass we can also see the substitutional defect, addition of copper.